NEC Section 517 does not specifically mandate an emergency generator for methadone clinics. However, it's crucial to understand that the code necessitates the provision of essential electrical systems. These systems are vital for upholding patient safety and ensuring a degree of comfort during any power interruption. The essential systems cover several key areas. Firstly, lighting is required for patient care areas, corridors, and stairwells to ensure safe navigation and continued care. Secondly, power is needed for medical equipment and appliances, encompassing refrigerators and freezers to preserve medications and medical supplies. Thirdly, adequate ventilation systems must be operational to maintain air quality and prevent the buildup of hazardous substances. Fourthly, functional fire alarm and emergency communication systems are necessary to alert occupants of potential dangers and facilitate communication with emergency services. Fifthly, security systems must be active to protect patients, staff, and assets. The decision of whether or not an emergency generator is needed hinges on the clinic's specific layout and design, along with the applicable local building codes and regulations. It's essential to remember that the interpretation and application of the NEC can vary depending on the jurisdiction. If there is any uncertainty, it's always advisable to consult with a qualified electrical engineer or the local building inspector. They can provide expert guidance tailored to the specific project and ensure compliance with all relevant requirements. To further clarify the requirements, let's delve deeper into each of the essential electrical systems mentioned in NEC Section 517. Starting with lighting for patient care areas, corridors, and stairwells, the intent is to provide sufficient illumination for medical staff to administer care effectively and for patients and staff to move safely throughout the facility. The specific light levels required may be dictated by local building codes or healthcare facility guidelines. These requirements often specify minimum foot candle levels for various areas within the clinic. Emergency lighting systems typically employ battery backup or generator power to ensure that these critical areas remain illuminated during a power outage. Next, the power requirements for medical equipment and appliances, including refrigerators and freezers, are crucial for maintaining the integrity of medications and medical supplies. Many medications require refrigeration to remain effective, and a power outage could compromise their stability. Similarly, freezers are used to store vaccines and other temperature-sensitive materials. The NEC requires that these essential appliances be connected to an emergency power source to prevent spoilage or loss of critical medical supplies. This emergency power source can be either a generator or a battery backup system. Ventilation systems are also considered essential because they play a vital role in maintaining air quality and preventing the buildup of hazardous substances. In a methadone clinic, ventilation is especially important to remove odors and ensure proper air circulation. The NEC requires that ventilation systems serving critical areas be connected to an emergency power source to maintain a safe and healthy environment for patients and staff. The specific ventilation requirements may vary depending on the size and layout of the clinic, as well as the types of activities performed within the facility. Fire alarm and emergency communication systems are essential for protecting the occupants of the clinic in the event of a fire or other emergency. These systems typically include smoke detectors, fire alarm panels, and audible and visual alarms. The NEC requires that these systems be connected to an emergency power source to ensure that they remain operational during a power outage. Emergency communication systems may also include two-way radios or other communication devices that allow staff to communicate with emergency responders. Security systems are becoming increasingly important in healthcare facilities to protect patients, staff, and assets. These systems may include surveillance cameras, access control systems, and intrusion detection systems. The NEC requires that security systems serving critical areas be connected to an emergency power source to ensure that they remain operational during a power outage. The specific security requirements may vary depending on the size and layout of the clinic, as well as the types of security risks that are present. Beyond the specific requirements for essential electrical systems, the NEC also addresses other aspects of electrical safety in healthcare facilities. For example, the code requires that all electrical equipment be properly grounded to prevent electrical shock hazards. It also requires that healthcare facilities have a comprehensive electrical maintenance program to ensure that electrical systems are properly maintained and operated. This program should include regular inspections, testing, and maintenance of all electrical equipment. When determining whether or not an emergency generator is required for a methadone clinic, it is important to consider the specific needs of the patients and staff. For example, if the clinic provides treatment to patients with serious medical conditions, it may be necessary to have an emergency generator to ensure that critical medical equipment remains operational during a power outage. Similarly, if the clinic is located in an area that is prone to power outages, it may be necessary to have an emergency generator to ensure that essential services are not interrupted. Local building codes and regulations also play a significant role in determining whether or not an emergency generator is required. Many jurisdictions have adopted codes that require emergency generators for healthcare facilities, regardless of the specific services they provide. These codes are typically based on the International Building Code or the National Fire Protection Association's Life Safety Code. It is important to consult with the local building inspector to determine the specific requirements that apply to the project. In addition to the NEC and local building codes, there may be other relevant standards and guidelines that should be considered. For example, the Joint Commission, which accredits healthcare organizations, has standards related to emergency power systems. These standards address the design, installation, and maintenance of emergency power systems in healthcare facilities. Compliance with these standards may be required for accreditation. When designing the electrical system for a methadone clinic, it is essential to work with a qualified electrical engineer. An electrical engineer can assess the specific needs of the clinic and ensure that the electrical system is designed and installed in accordance with all applicable codes and standards. The electrical engineer can also help to determine whether or not an emergency generator is required and, if so, what size and type of generator is needed. The selection of an emergency generator should be based on several factors, including the size of the load that needs to be supported, the type of fuel that is available, and the level of reliability that is required. Generators are typically rated in kilowatts, and the size of the generator should be sufficient to handle the peak load of the essential electrical systems. The type of fuel that is used to power the generator can also affect its reliability and operating costs. Natural gas generators are typically more reliable than diesel generators, but they may not be available in all areas. The installation of an emergency generator should be performed by a qualified electrical contractor. The contractor should be familiar with all applicable codes and standards and should have experience installing generators in healthcare facilities. The installation should include proper grounding, wiring, and ventilation to ensure that the generator operates safely and reliably. Once the emergency generator is installed, it is important to have a regular maintenance program to ensure that it remains operational. This program should include regular inspections, testing, and maintenance of all generator components. The generator should also be tested periodically under load to verify that it is capable of supporting the essential electrical systems. In summary, while NEC Section 517 does not explicitly require an emergency generator for methadone clinics, it does require that essential electrical systems be provided to maintain patient safety and comfort during a power outage. The specific requirements for these systems will depend on the layout and design of the clinic, as well as the local building codes and regulations. It is always best to consult with a qualified electrical engineer or the local building inspector to ensure compliance with all applicable requirements. Remember that lighting for patient care areas, corridors, and stairwells must be adequate. Power for medical equipment and appliances, including refrigerators and freezers, must be available. Ventilation systems must be functional, fire alarm and emergency communication systems must be operational, and security systems must be active. Carefully consider all relevant factors and consult with experts to ensure a safe and compliant electrical system for the methadone clinic. In a typical scenario, the electrical engineer will conduct a load calculation to determine the total power demand of the essential electrical systems. This calculation will take into account the lighting load, the power requirements of medical equipment and appliances, the ventilation system load, the fire alarm and emergency communication system load, and the security system load. The load calculation will also consider any other essential loads that need to be supported by the emergency generator. Once the load calculation is complete, the electrical engineer can select an emergency generator that is sized appropriately for the load. The generator should have sufficient capacity to handle the peak load of the essential electrical systems, with some margin for future expansion. The generator should also be capable of starting and running under load without experiencing any voltage drops or frequency fluctuations. The electrical engineer will also design the transfer switch system that will automatically switch the essential electrical systems from the normal power source to the emergency generator in the event of a power outage. The transfer switch system should be designed to minimize the interruption of power to the essential electrical systems during the transfer. The transfer switch system should also be designed to prevent the emergency generator from backfeeding into the normal power source. The electrical contractor will install the emergency generator and transfer switch system in accordance with all applicable codes and standards. The contractor will also ensure that the generator is properly grounded, wired, and ventilated. The contractor will also test the generator and transfer switch system to verify that they are operating correctly. The facility owner is responsible for maintaining the emergency generator in accordance with the manufacturer's recommendations. The maintenance program should include regular inspections, testing, and maintenance of all generator components. The generator should also be tested periodically under load to verify that it is capable of supporting the essential electrical systems. The facility owner should also keep accurate records of all maintenance and testing activities. Let's consider a hypothetical example to illustrate the process of determining whether or not an emergency generator is required for a methadone clinic. Suppose that a methadone clinic is located in a jurisdiction that has adopted the International Building Code. The International Building Code requires that healthcare facilities have emergency power systems that are capable of providing power to essential electrical systems for a minimum of 2 hours. The methadone clinic has the following essential electrical systems: lighting for patient care areas, corridors, and stairwells, power for medical equipment and appliances, including refrigerators and freezers, ventilation systems, fire alarm and emergency communication systems, security systems. The electrical engineer conducts a load calculation and determines that the total power demand of the essential electrical systems is 50 kilowatts. Based on the load calculation and the requirements of the International Building Code, the electrical engineer recommends that the methadone clinic install a 60 kilowatt emergency generator. The generator should be capable of providing power to the essential electrical systems for a minimum of 2 hours. The generator should also be equipped with an automatic transfer switch that will automatically switch the essential electrical systems from the normal power source to the emergency generator in the event of a power outage. The electrical contractor installs the emergency generator and automatic transfer switch in accordance with all applicable codes and standards. The contractor also tests the generator and transfer switch to verify that they are operating correctly. The facility owner establishes a maintenance program to ensure that the generator is properly maintained and tested on a regular basis. This example illustrates the importance of consulting with a qualified electrical engineer and complying with all applicable codes and standards when designing the electrical system for a methadone clinic. By taking these steps, it is possible to ensure that the clinic has a safe and reliable electrical system that will protect patients and staff in the event of a power outage. It is also crucial to have documentation showing these steps were taken and by whom.